Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching videos of thermodynamics in English. Okay, so today is Saturday and we are seeing the English videos. In our last lectures, we have studied about isothermal processes for the ideal gases, and now we will see the isothermal process for the real gases. Real gases means that are van der Waals gases. It means that are following the van der Waals equation. So first of all, see the work done in the isothermal reversible process for the real gases. See here, for the real gases, we know when we are taking the real gases, what we use? We use the van der Waals equation. And what is the equation? P plus A n square upon V square, V minus NV is equal to nRT. Okay, so now we have to use this equation instead of the ideal gas equation. So now we have to find out the pressure term, this term we have to find out. Okay, so put all the terms to the side. Okay, so what we are getting? nRT upon V minus NV minus an square upon V square. Okay, now we have the value of P and we have to find out work done, W. That is given by minus integration of P dV. Okay. So just you have to put here the value of P. So what is the value? nRT upon V minus NV dV. Minus, we are separating the terms. Okay. So we are writing here separately. An square upon V square dV. Alright, now you have to do the integration. So what you are getting? Minus nRT natural log of V2 minus NV upon V1 minus NV plus an square 1 upon V1 minus 1 upon V2. We are doing the integration of 1 upon V square. So we are getting 1 upon V1 minus 1 upon V2. Okay. So this is the equation that you have to find out for the work done. Just you have to put here the values and you can find out the work done. Now the second thing is the change in the internal energy for the real gases. We know the formula for the internal energy change. It means del U for the real gases. We have seen in the lecture of internal energy change. Okay, I have already made a video on the internal energy. So you can see that lecture. You can go to you can see the description box and you can find out the lecture. Del U is equal to N CVM del T plus AN square 1 upon V1 minus 1 upon V2. Okay, this is for the real gases. Now we know that for the isothermal process, del T is equal to 0. Okay, so this term will get equal to 0. Okay, so now del U will be equal to an square 1 upon V1 minus 1 upon V2. Okay, so this will be the formula for the internal energy change for the isothermal processes in the real gases. Okay, we have seen that for the ideal gases the del U was equal to 0, but this is not equal to 0 for the real gases. Okay, now the next thing that you have to calculate is the heat change in the isothermal process for the real gases. We know that according to the first law of thermodynamics, Q plus W is equal to del U. Okay, so Q will be equal to del U minus W. Okay, so just you have to put here the value of del U. So what you are getting? Q is equal to an square 1 minus V1 minus 1 upon V2. Okay, now put the value of W. So 2.303 nRT logarithm of V1 minus NV upon V2 minus NV plus an square 1 upon V1 minus 1 upon V2. Now see here, this term and this term. Okay, this will cancel out. So what we are getting? Q will be equal to 2.303 nRT logarithm of V1 minus NV upon V2 minus NV. Okay, so this will be negative term. This is your formula for the calculation of heat transferred. Okay, if you want to remove this sign, if you want to remove the negative sign, then what you can do? You will change the terms behind the logarithm. It means you can write logarithm of V2 minus NV upon V1 minus NV. In this way, you have to invert it. Okay, so that you will get all the positive term. So this is the formula for the heat change. Now the next thing is the enthalpy change in the isothermal process for the real gas. We know enthalpy change is given by del H is equal to del U plus delta PV. This will be equal to del U plus P2 V2 minus P1 V1. Okay, so what we are getting, del H is equal to an square 1 upon V1 minus 1 upon V2 plus P2 V2 minus P1 V1. This will be the formula for calculating the enthalpy change in the isothermal processes for the real gases. Okay, so this is all for the isothermal processes in the case of real gases. You can do all the calculations, just you have to put here the values and you can find out your answers. Okay, the next thing that you have to study is the adiabatic process. Both the processes are equally important, isothermal process as well as the adiabatic process, because the questions are asked from every topic. Okay, so in our next lecture we will study about the adiabatic process. We will see all the calculation terms, how to apply for the graphs, so that you can do all the questions easily. Okay, so meet you in the next video. Hope you will like this video. If you are liking, please comment me, please subscribe the channel and please share the video. Thank you.